What's going on, dudes and dudettes? I know we've got some funky monkey on the thing, funky monkey on the computer screen right now. But what we're gonna be doing is we are gonna just be trying some stuff out. Can you guys see all right? Is the audio or is the visual coming through all right? I know. It's gonna look a little funky. Is the video coming through? Let me try this. What about that? Is that coming through? Talk to me, folks. I need it back. All right. So this is hello. Hopefully you guys can see that. Let's see if I stand back. But lean forward, it doesn't work. But in that. All right. Another thing I'm going to try is I'm going to just try taking off all of these effects. Give me a second, I'm so sorry. I'm just kind of testing things out and trying to see how they work. Hopefully I can get this thing to really work well. Give me a second. I'm just testing things out. Alright, to be honest with you, for now, I kind of like the normal view the best. It's less cray-cray. Alright, let's see. Do you guys read that? Is that good for you? Alright, cool. Awesome. And the audio, is the audio coming through all right? Okay, good. Let's get class started. Let me just move this because it's starting. Let me just erase this because it's really distracting to me. Let's get a nice clean setup over here. Don't get started. Alright, what's going on, folks? Today what we're going to do is we're going to go over a few computing slopes problems. I want to get through this quickly because I feel like slopes is actually something that you've learned in the past. And so I don't want to keep beating the dead horse because it's dead. By the way, is the video too dark? Should I try lightening that up? Let's see, where's my eyeglass demo? Feels like it's dark. Let me just look eyeglass, there we go. Alright, let's see. I want to adjust the brightness up. There we go. I'm actually not sitting in a dark office, I'm sitting in a lighted office, so it should work better that way. Can you guys see me alright? You good? Awesome. Alright, so what we're going to be doing is we're going to be doing computing slopes. We're going to be checking that out. Now, in many cases, alright, so I'm on this page right now. In many cases, a slope is very easy to identify and it's easy to compute. All you got to do is rise over run. I taught you the methods. We went through this. Actually, I don't know why I'm starting on this page because we actually did this. Alright. Now let's move on. But let me ask before I move on, do you guys feel good about how to compute a slope? Because I did one of these problems for you. You guys feel good about this? If I can move on, just say move. If I can't, then say no. Come on, talk to me, folks. I need you guys to be interactive here. If you want me to move on, say move. If you want me to redo it, I can do it, but just let me know. Which papers are we doing? I'm on. I think this is Algebra 1.1. We're talking about functions. Let's see. In your class, you guys should be about here. You guys should be. Let's see. Yeah, we're about doing the right thing here. So we wanted to cover page 16 to 18 at least today. So I'm going to move on, if that's cool. because this is talking about how to compute functions. Let's see. Yeah, we want to cover page 16 to 18. Please stay. Alright, so 7. You guys can kind of skip these. You guys don't need to do this one. You guys don't need to do this one. Should I cover it? Let me just see. Alright, I'll tell you what. Why don't I pull up page 10. I'm going to pull up page 10. I'm going to do a few problems from you. We'll talk about those and then we'll move on. Cool? Alright. Tammy likes to swim laps in her pool. In her big Olympic-sized pool. Dude, Tammy's rich. For her workout, she swims 10 laps in 20 minutes. If T represents the number of laps that Tammy can swim in M minutes, what is the slope of T? Okay, alright, so I guess if you were to have a graph, and each lap takes her, she can swim 10 laps in 20 minutes. 20 minutes, she'll get 10 laps done. So this is L, and this is time. We cool? I'm just kind of trying to think of this as a graph. Oh, wait. I'm doing the wrong problem. Sorry. No wonder. Yeah, you're right. Dudes, wait up. Hold on. Calm down. I'm looking at page 10. I'm looking at it now. All right, sorry. I kind of wanted to do that. I did that on purpose. I was wondering if you guys paid attention. All right. Linear functions can be written in the form fx equals mx plus b, where m and b are numbers that are and x is the independent variable. Right. Remember, we have y equals mx plus b. This guy is the independent variable. This guy is the dependent variable. M is the slope, and b is the intercept. We cool with that? Do you know why this is called the independent variable and this is called the dependent variable? Say yes, IDK. Throw it out there. Do you know why this is the independent variable and this is the dependent variable? I'll tell you, it's actually really easy, really straightforward to think about. Yes, exactly, because if you change, remember how I told you a function is like a relationship. It relates something coming in to something going out, right? So the thing coming out is this y, which would imply the thing going in is this x over here. So you have an input and an output. That's why, at least for me, it's easier for me to memorize that the y variable is the dependent variable. Why? Because it depends on what came in, right? What comes out depends on what came in the first place. So that's why it's the dependent variable, and then ergo, that makes this the independent variable, or independent variable. We cool? That's why it's called the independent variable and the dependent variable. All right. Note, if your independent variable has contextual meaning such as time, as was in the last case of the previous handout, x, and it can often have a different variable. We don't always have to make this x, we can always make it t. Time. We can actually make it anything we want. We don't even need to make it t or x or whatever. We can make it k or m. I think, actually, you probably would want to stay away from using the variable m. Anyone know why? Think about it. Why would we not want to use m as the variable? Yeah, the m is the slope already. But what I meant to say was, remember when we were doing a function where it was dependent on the number of movies you would rent? Like how much money it would pay depends on how many movies you rented that day. And we talked about Redbox and Netflix and all that kind of stuff. That's why I would think that maybe you could use m if you were talking about movies. But then I thought about it and I said, no, we'll probably stick with x on that one. Because I don't want to confuse m as a variable with m as my slope. That's just, that's just me. I probably also don't want to use b as my variable. That would confuse me with these two. So you could use anything you want except M and B and a few other things. But, I mean, and that's not because you can't do it, just because I think that if you do it, it will confuse you. We cool? Yes? Good? Bad? Ugly? Good? Bad? Ugly? Alright, awesome. Let's see, what do we got? If you're independent, alright, so what we have here is they gave us like g of x is equal to negative 2x plus 3. So basically what you're saying is, give me an x and I'll tell you what g of x is. So then they say, okay, give me a g of x, and then basically if I give you an x, and you can make a table for me and you go negative 2, negative 1, 0, 1, 2, and 3, then you input these guys over here, and then your output would be over here. So this would be x column, and then this would be the g column. Does that make sense? So you take this x as negative 2 and you plug them in here. Let's see, negative 2, and if x were negative 2, that would be positive 4 plus 3, that's 7. And then the negative 1 in here, that becomes negative 2, negative 1, that's positive 2 plus 3 is 5. And then 0 over here is 3, and then 1 over here would be 1, and then 2 over here would be negative 4, negative 1, and then 3 over here would be, take that 3, put it in here, that would be negative 6, that would be negative 3. Did I just go too fast for you? You guys are able to grab that table pretty quickly. Come on, good, bad, ugly? Good, bad, ugly? Good, bad, ugly? Yeah, we'll do that. Good, bad, ugly? Alright, awesome. If I were to graph this, I would simply plot the points. That's what I would personally do. So if I were to graph this, I would say, alright, fine. Oh, I probably should put the vertical line right here. Negative 2 goes up to 7, then negative 1 goes to 5, then we got 3, then we got 1, then we got negative 1, then we got negative 3. So it would look like something like that. Cool? Yes? I like it? I don't like it? Come on, talk to me, folks. Alright. So these are the 3 different ways to represent the graph. We have the equation, we have the table, and we have the picture, the graph. Now, those are 3 different ways to represent the function. Another way you can represent the function is just talking about it. That's the long-winded way that English majors like to choose. I'm not a big fan of it because I just don't like typing things out or writing things down. I'm a big fan of just drawing things. All right, let's see. Reflection. What does M in each formula tell us about the graph? All right. Oh, I see. They're just asking. So what is M telling us about? What is M again? Oh, wait. Putting my hand over there, it doesn't work. What is M? It's a slope. It tells us how high it goes up versus how far across it goes. Now, in this case, this slope goes down as it goes to the right. So this would be a negative slope, as we can see by the negative 2. Now, what is the B in this case? Well, the B is the intercept. It's where the dang thing crosses the x-axis, the y-axis, the vertical. It's the y. Why did I say the x-axis? It's the y-axis, of course, because it's called the y-intercept. It's what does this represent? It's called the y-intercept. So it's where the thing crosses the y-axis. Make sense? Good? Bad? Ugly? All right, awesome. I'm going to erase. Can I erase? All right, take a picture. Ready? 1, 2, 3. Take a screenshot if you want. By the way, have you guys been able to figure out those screenshots? Those work out for you? Yes? No? I need you to type. Awesome. Does that help you with taking notes? That way you don't have to feel the pressure to write everything down. You can just write things, take notes on that. All right, let's see. Match the following equations. So we're on the next page right here. Match the following equations. Match each equation below with the graph and fill in the corresponding letter. All right, fine. Let's see. I'm actually going to maximize this thing, and we'll just take a look at this thing together. All right, let's play matchy-matchy. What do we got here? Let's look at A. A has what kind of slope? Positive or negative? It's a negative slope, exactly. So we just look for the one that has a negative slope. Okay, which one of these? It could either be this one or this one, and those are the only two that it could be. Now, is it negative? How do you know which one it is? I guess that's my other question. Is it this one over here, or is it this one over here? It's the first one or the second one. I'm writing with mouse. It's the one with the negative 2. Why? Why, Kaylin? How did you figure that out so quickly? What are your thought process there? What did you look at? It goes up 2 and over 1. You mean that it goes down 2 and over 1. That's what you mean, right? It goes down 2 over 1. We're looking at A, right? So start at 4, you go down 2, across 1. You go down 2, across 1, and there you are. Boom, you're at another point. You go down 2, across 1. Does that make sense? Yes, absolutely. To be honest with you, I think that there was an easier way to look at it. I just kind of looked at, all right, it can't be this one. That's supposed to be an X, folks. I'm sorry. I'm terrible at drawing with this mouse. This is A. Give me a second. Give me a second. This takes concentration, folks. There we go. Why can't it be this one? Well, because take a look at the intercept. I mean, if the intercept over here says it's positive 1, does A intercept at positive 1? No. So therefore, it's not the answer. Boom, right off the bat. I knew the answer was got to be this one. And 9 halves. Okay, is this intercept 9 halves? It could be. 9 halves is 9 divided by 2, which is, all right, what is 8 divided by 2? That's 4. So that's 4.5. So does this cross at about 4.5? Would you say that's true? Say yes, no, good, yes. Talk to me, folks. I need you to talk back to me. Yeah, awesome, awesome. Hey, keep in mind that there's going to be a lot of waiting in this class if you guys don't talk. I know it's tough because I'm expecting you to take notes, to type to me, and to watch the video all at the same time. But remember, I'm a mean teacher like that, so deal with it. Ha. All right, let's see. Do you guys think you guys got this down? Can we move on? All right, I'm moving on. Moving on up. What do we got here? Next page. Keone's piggy bank started off at $23, and each week at the end he added $5 of his weekly allowance. Let f of x represent the amount in his piggy bank. I'm going to do page 12, number B. Ooh. Part B. Okay, so you ready? Dude's piggy bank started off at $23. So we got f of x, and we want to make it some function of x. If the dude started off at $23 at time equals 0, at x equals 0, maybe I'm going to put t instead. Or how's about W? Let's put a W in here. Instead of using an f of x, I'm putting f of w. Why would I use w? Because I'm talking about the number of weeks. So after the first week, after the second week, after the third week, so I think w would probably be a more appropriate variable to use. Fine. At week 0, how much money does he have? At week 0, how much money does he have? $0? No! At week 0, how much money is in his piggy bank? 23, exactly. It says right here, Keone's piggy bank started off with 23 bucks. Got it. 23. Every week after that, he added $5, so you just put 5W because you want to add $5. That 23 is the y-intercept. The 5 is the slope. If you started off with more money, you change this number. If he adds more allowance, he gets a raise in his allowance, you can change this number. Making sense to you? Makes sense to me. Good? Bad? Ugly? Well, it's kind of easy. I think it was easy. I don't know. You don't need to think it's easy. You just need to do it. Yes? Oh, we're going to move on. All right, let's see. What else do they got? Slope-intercept form of a line. Let's see. Suppose that f of 1 is equal to blah, and f of x plus 1 equals... Okay. All right. Well, let's go over this one because I actually didn't read this one to get prepared for it. Let's get this party going. And I'll tell you what I'm going to do is I'm going to record this file, and then let's see. We started off at 9 o'clock. Why don't we go till 9:40? I'll give you a 10-minute break, and then we'll start class up again at 9:50, and then we'll go to 10:30, and then that's it. Sound good? 9:40, 10-minute break, 9:50. Yeah, this class runs from 9 o'clock to 10:30, so that's what I was told to do. So that's the way we roll. And then I think after that, most of you jump into chemistry at 10:30. Is that correct? I mean, I hate to say it, but think of it from my side. I got to get through. I got to go through classes from 9 o'clock to 1 o'clock with 10-minute breaks in between. That's it. So anyway. Oh, wait a second. All right. So wait, Kaylin, you have Modern History of Hawaii at 9:45. Okay. I'll tell you what. Why don't we end this class at 9:45, and we'll be all right. To be honest with you, technically, I think this class is supposed to go to 10:30. I'm going to have to check that, double check that. I'll talk to your history teacher. But today, since we didn't have that communication going, why don't we finish at 9:45? I'm fine with that. Then if it's all right with you, I'm going to start skipping over some pages because I really want to get through page 16, 17, and 18 because that's your homework. So if I can get through those pages, then at least I can kind of start helping you out with what we're doing here. Sound good? And I realize that if once I start whispering, I don't know if you guys can hear me. That's your homework. Can you guys hear me? Was that all right? I said that's your homework, by the way. 16, 17, and 18. All right, anyway. I'll tell you what. I'll do one problem from 16. I'll do two problems from 17. And then I'll do one of these from 18, which doesn't look like we have to do much. I don't understand what 18 is. In fact, I might actually just delete that part. But let's see. All right. Ready? You choose. I'll let you choose one of the problems I'm going to do from page 16. Go. Do I do problem 1, 2, 3, or 4? Choose. If you don't choose, I'm not going to do any of them. So choose. Problem 4. Okay? Let's see. Find the symbolic representation of each function. Place your answers in the areas provided. Okay, good. Fine. Choose the hardest one for Mr. Dalday to do. I guess that's pretty smart, right? If I told you I'm going to do one problem, you're going to choose the hardest one. All right, let's see. One of the points that we know of is out here at 4 comma negative 19 over 2. So that's like 11 and a half. No, is that 11? That's like 20 divided by 2 is 10. So that would be, that's like 9 and a half. All right. And then over here is negative 3 comma 8. Can you guys see that all right? And I'm going to connect the dots. Woo! We good? All right. So, I got 2 points. What's my slope? I mean, there's some equations I'm going to run through it. But remember, I'm not a big fan of those equations. Remember, I'm teaching you guys how to do this without doing any equation, or without memorizing equations. I just want you to understand a concept. So, what is the equation that I'm going to kind of look at? I want the slope. I want how far did it fall. If I'm going to go from this point to this point, how far did I have to go down? I think it's negative 17 and a half. Do you guys agree? No, not 17 and a half. It would be 8 plus 9. Yeah, 17. Yeah, negative 17 and a half. I was right. Agreed? Good, bad, ugly? Do you understand how I got that so quickly? Wait, you don't agree? Or you don't understand? If you don't understand, say IDK, so I can be clear about this. I ask you too many questions. You don't type fast enough. Well, you don't understand. Okay. Here. If I start here and I want to go to here, I told you that this thing is actually negative 19 and a half. I'm just going to round that off and not use fractions. I'm not a big fan of them. As 9.5. Right? And then what I'm going to do is I'm going to say, okay, this is 8. So if I fall from here all the way down to here, I would have to go down 17 and a half units. Do you understand now? Cool. What's my run? What is the run in this case? Would you write 7? Did you write 7? I can't see. 7. Awesome. Yes, that's exactly it. Because you need to, in order to get from here to here, you got to go 3 units and then another 4, so it's 7. So my slope is 17 over 5. 17.5 over 7. We happy with that so far? That's my slope. I'll label that as M. Alright? Then what I'll do is, you know what I'm going to do is I'm going to plug this into, I'm wondering if I should plug this into an equation. Remember I told you I'm not a big fan of equations. Here's the equation I would plug it into if I did. It would be y minus y1 equals m times x minus x1. And all I would do is I would take this m, put it here, and then take one of these points and put them in here, and then boom, Bob's your uncle. There's my equation right there. But I guess your question to me is, where did you get that equation, though? Right? Like, where did that equation come from? Why did you just use that one? Well, I'll tell you why I use this one. If you want to memorize equations, I would use this one because this is called the point slope formula. Not a big fan of memorizing formulas, but this is called the point slope formula, and that means if you have a point, which you have two of them, but I mean, if you have at least one, you'll be good. And if you have the slope, which we do, then you can just plug it into the equation and say, yay, I'm done. But where did this equation come from? Why would I want to use this? Remember, I want you to kind of understand where we're getting this stuff from. So the slope, basically, I got it from this equation right here. Now this one you can kind of hang with, or at least I hope you can hang with. This is exactly what we used here. This says the slope equals rise over run. Because the rise was the difference in the heights, right? And the run was the difference in the horizontal distances, things. We good? Piquito? Yes? Understand? Alright. So all I did was I just said, alright, let's make this a general point instead of saying a specific point too. So I erased the 2 with my finger. And then I cleared fractions, and there we go. That's the point slope formula. So all I have to say is, okay, fine. Y minus, alright, let's choose a point. What do we want to use for y1, x1? Do we want to use this over here or this over here? Use this. Do we want to use the negative 3, 8, or do we want to use the 4, negative 19? Which one do you want to use? Yes, exactly. I would want to use negative 3, 8. Would you like to know why? Because it doesn't have any fractions. And I'm a big fan of no fractions. Alright, anyway. So for y1, I'm going to plug in an 8. For x1, I'm going to plug in a negative 3, so it would become positive 3 over here, because it's x minus x1, so it's x minus negative 3, which makes it x plus 3. And then for the m, I'll simply write negative 17.5 over 7. Do you understand what I did there? I'm just using the definition of slope. Slope equals rise over run. Boom. Bada bing, bada boom, Bob's your uncle. I have no idea where that term comes from. I think it's English. Anyway. Then all you got to do is solve for y. Get y all by itself. So you have y equals negative 17.5 over 7 times x plus 3 plus 8. What I would do is I would probably distribute that out. Then I have y equals negative 17.5 over 7x plus something. I don't know. I don't have a calculator on me, so I wouldn't know how to do that. We're cool? Take a picture. Let's move on. We've got to start class at 9:45, and I need to get you guys out of here, or else Modern History of Hawaii is going to start yelling at me. You don't want the Hawaiians yelling at me. All right, I'm going to erase. Picture, 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 go. 1, 2, 3. Command. And then the button above the 6. All right, we're erasing now. All right, let's do this one now. Okay, let's see. Lono has the I'll do the last one. The last one seems to be the hardest one, so let's just do that. You guys all right with that? Lono has the following sequence of numbers: 2, 8, 14, 20, and 26. He wants to represent this sequence symbolically in such a way that he is able to quickly determine the value of any term in his sequence. For example, if you wanted to know the third value of the function, you would put f3, which we already know is 14, if he wants the 100th term. Oh. Okay. You guys skip page 18. I have no idea what it's for. Just letting you know. All right. Okay. 2, 8, 14, 20, 26. What's the pattern here, folks? Trying to figure out how to represent this as a function. Yeah, add 6, exactly. So 6, 6, 6, 6. All right. So plus 6, so on and so forth. All right. Then my function, which is a function of x, is equal to, if you put in 1, I want it to spit out 2. I think it's going to be 6x plus 2. Yes. I think that's going to work. No, wait. That will work. All right, here's my thoughts. All right. I know I just wrote it down, and that's cheating because I didn't show you my thought process. I just said, boom, here's the answer. I think it works. Let's verify that this works, and then I'll show you my logic that I kind of went through for this one. Is that all right with you guys? I know it's a little funky. Why did I add in the x minus 1? All right. Let's prove that this works. If we plug in 1 over here, we should get 2 out. So 1 over here becomes 1 minus 1, which is 0. 0 times 6 is 0, plus 2 is 2. Good. If we plug in a 2 here, we should get an 8 out. 2 minus 1 is 2, or 2 minus 1 is 1, times 6 is 6, plus 2 is 8. Boom, we're good. You see how this equation does in fact work? Right? Now, ask me, the obvious question, where did you get that though, Mr. Dalde? That's crazy. Did you just pull that out of your brain? And I said, yes, I did pull it out of my brain. But here's the logic behind this. I said, it goes up by 6. So if I wanted to get to this mark over here, I would have to go 6. I would have to go up 6 4 times. And guess what? This is the 5th position. Right? This is the 1st position, 2nd, 3rd, 4th position. This is the 5th number in that sequence. So if I wanted to get to this number, 20, I would have to go up by 6 how many times? 1, 2 times. Oh, no, 1, 2, 3 to get to the 20? Yeah. So 1, 2, 3. I would have to go up 3 times. If I wanted to get to the 4th position, I would go up 3 times. If I wanted to get to the 5th position, I would go up by 6 by 4 times. So that's kind of why I added in that x minus 1, because I noticed that if whatever position I'm sitting at, I would go up 1 less amount of times by 6. And I multiplied by 6, that's how I know that that was kind of my slope. And the reason why I put 2 at the end is because I figured that is kind of like my intercept. At the initial position, my answer is 2. Does that make sense to you? This is kind of how I got about that. Anyway, we're out of time. You guys are late for class. I'll see you later. Bob's your uncle. All right. Bye.
You are currently the only person in the